Alright, now I'm going to do a tangent graph, and you can apply the same principle to the cotangent graph as well. So we'll just do a tangent graph. And let's do 2 plus 3 tangent of 1/2 x plus pi. Okay. So all kinds of different transformations that have happened here. We've got the 1/2 is going to widen the tangent function. The pi is going to shift. It's going to shift to the left. The 3 is going to stretch it vertically, and the 2 is going to increase. It's going to shift it up 2 units. So lots of different transformations. And we know that you can certainly graph the tangent function using these transformations, but it's easiest if you use the mechanical approach and then use the transformation rules to check your work. Okay? So, same principle still applies. Let's calculate the period. For tangent, the period is, instead of 2 pi over b, it's just pi over b. Okay, so here we go. Pi over b. b is 1/2. Dividing by 1/2 is the same as multiplying by 2. So the period of this function is going to be 2 pi. Now what we do, same thing as before, take the period over 4. And now, with that period over 4, with the sine and cosine graphs, what we did, we started at the starting point and we added the period over 4 multiple times. What we're going to do for the tangent, we're actually going to add it a couple of times going right and subtract it a couple of times going left, for reasons we'll see in a little bit. Okay. Let's also find the phase shift. That gives us our starting point. So same thing as before, set the inside equal to 0, and solve for x. So we get 1/2 x equal to negative pi, or in other words, x is negative 2 pi. So that gives us our new starting point, the phase shift. Okay. So with these couple of values, phase shift and the period over 4, we're going to set up the key points for the tangent function. So our phase shift happened at negative 2 pi. And what we do for the tangent function, we take the period over 4, and we add a couple of copies from this starting point, a couple of copies going right, and a couple of copies going left. So, I'm going to input a couple of reference points here, negative pi, 0. So, the period over 4 was pi over 2, and so we add that a couple of times. Negative 2 pi plus pi over 2 is going to give us this key point right here, which is negative 3 pi over 2. Just doing some fraction arithmetic there. Same thing here. Add the period over 4. Negative 3 pi over 2 plus pi over 2 puts us right here at negative pi. So there's one key point here, one key point here, another key point here. And we also take the period over 4 and move to the left a couple of units. So negative 2 pi minus period over 4 is going to be minus 5 pi over 2. And one more copy here, minus 3 pi. Okay, now these key points are going to give us one period of the tangent function, and then to get additional periods, you just add more copies of the period over 4. So now that we have these key points, we plug them into the tangent function. So if this is f, what do we do? F at the first key point, negative 2 pi. Well, let's start at the far left, negative 3 pi. We get 2 plus 3 tangent of 1/2 x plus pi. And if you know your basic tangent function real well, the basic tangent function has vertical asymptotes at plus and minus pi over 2. And then it starts in the middle and approaches the asymptotes in either direction. So if you know this basic tangent function real well, then you can expect the following points to come out of these inside pieces. Negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So we secretly know these points already, and so what we do, we skip all the arithmetic, and we know this is all going to simplify down to negative pi over 2. Tangent negative pi over 2, that's undefined. And so we've got this vertical asymptote right here, negative 3 pi. Okay. And that's awesome, because once we know where one of those vertical asymptotes happens, all we have to do is go one period over, and we know where the other asymptote happens. Okay, so here we go. The period here is 2 pi. If we start at negative 3 pi, one period over would be negative pi, and that automatically gives us a second asymptote. Okay. Now that we have these, we know the tangent function is going to be in between them, and we just need to basically locate it, right? So that's what these middle points do for us. Let's go ahead and compute the middle values. F at negative 5 pi over 2. 2 plus 3 tangent of 1/2 5 pi over 2. Negative 5 pi over 2 plus pi. And again, we know the basic tangent function has a key point at negative pi over 4, so automatically we know this inside simplifies down to negative pi over 4, and then tangent negative pi over 4 is negative 1. So we get 2 plus 3 times negative 1, which is negative 1. Okay? So that's our next key point, right here. The y value is negative 1. The next key point for the basic tangent function occurs at 0, so we know the inside of this tangent function is going to simplify down to 0. Let's go ahead and input our next key point, negative 2 pi. So we get 1/2 of negative 2 pi plus pi. This we know is going to simplify down to 0, right? And there it is, 1/2 of negative 2 pi is negative pi plus pi, so that's 0. And tangent of 0 we know is 0, so the y value here is 2. Okay. And then we can input this guy, f at negative 3/2 pi. You'd end up with 2 plus 3 tangent of pi over 4, right? You're just going to get the next key point on the graph. Tangent pi over 4 is 1. So we get y value of 5. Okay. And now we've got these 3 key points and we've got the asymptotes, so we just connect the dots in between them. You're going to be asymptotically approaching from the left. Flattens out near the middle, and then asymptotically continues to the right. So that got a little bit ugly there. Okay. So there is one period of this tangent function. We then proceed to add multiple copies of the period over 4 again, and draw the tangent function in between those asymptotes. And then you can check your work by saying, what do I know is supposed to happen to this tangent function? First of all, the 1/2 says it's going to be stretched. The normal tangent function has a period of pi. This thing happened to have a period 2 pi, so it's stretched just like we expected. The plus pi says the starting point is going to shift to the left, which it did. Here's our starting point, whereas the normal tangent function starts at 0. The 3 says it's going to be shifted vertically by a factor of 3. And sure enough, we notice that here's the midpoint, and it's the y values are 3 times as spread out from this midpoint as they are in the original. And we also see that it should be shifted up 2 units. The the original goes through the x-axis, that the midpoint is in the x-axis. Here the midpoint has been shifted up 2 units, okay? So the mechanics here allow you to plot the graph, and then the features of the trig function allow you to check your work, okay? The transformations that happen to the trig function. You just make sure all those transformations went through correctly, okay?